Alright, now welcome to this video, and in this lesson we have been asked to check whether this this function h of x equals g composite of f of x is continuous at x equals 3 of this piecewise function given g of x equals root of x. In other words, we have been asked to check if h of x is continuous at x equals 3. So let's do that. But first of all, what I want to do here is to check, is f of x continuous to begin with? At least use that as a basis. They ask you to check whether h of x is continuous, given that this man is continuous, but you should check, is this true before I continue? So let us check, is f of x continuous at x equals 3. The three conditions says that f of a must exist, and this is x equals to 3 and this is equal to a. So the first condition says that f of a must be defined. Now, is f of a defined? F of a equals to f of 2 and equals, f of 3 and equals, where do we have x equals 3 here? Here we have s above 3. Here we have x less than 3 or equal to 3. So here, because we have here equal to 3 here, we use this equation. So we use x squared minus 1 equals to 3 squared minus 1 equals 9 minus 1, which is equal to 8. The second condition says that the limit of this function must exist from both sides. Now let us check the limit of this function from the left and see what we get. So the limit as x approaches 3 from the left, where do we have x approaching this man from the left here? This is it, right? Yes, as we have explained before. So here we still use x squared minus 1. So we have x squared minus 1 equals 3 squared minus 1, as we have here, always equal 8. And check the limit as well, as x approaches 3 from the right. From the right implies this, so we use 2x plus 1. So 2x plus 1 becomes 2 into 3 plus 1. Plus 1 is equal to 6 plus 1 is 7. So as you can see, this the last condition says that the limit as x approaches a from either side of f of x must equal f of a. But that is not true, because the limit does not match each other. So we can see here that the limit as x approaches 3 of f of x from the left does not equal the limit as x approaches 3 from the right of f of x. Does not equal. So we can say that this also fails. So if this fails, it fails because here we have 8 and 7, and here we have 8. These numbers, they do not match, which means that f of x is discontinuous at s equals 3. So let us check for h of x as well. Now for h of x, h of x says that h of x is equal to, are you seeing that? See, is here. H of x is equal to g composed of f of x, and g is root of x. So we simply have root of f of x there. So now let us check the limit of this function, or let us first of all check this function at x equals 3. So we are finding this function, that is not f of a now, we are finding h of a now in this case. So h of a will be equal to h of 3, which will be equal to, where s is 3 is still s squared plus 1 is still s squared plus 1. But if you are going to use according to this man here, where x is equal to this here, you will be having the root of f of x now. of f of x now, let us see of f of x. Are you seeing that? Where x is equal to 3, here we have 8. So the root of 8. Now the root of 8 here implies we have 4 by 2, and this is a surd, and 4 by 2 simply stands for 2 root of 2. Now we have checked if h of a is defined, and it is defined. Now 2 now is to check the limit of h of a of 3, sorry, from the left. Now h of a from the left, now this will give us root of everything that implies f of x from the left, and f of x from the left is this man here. Are you seeing that? F of x from the left is this man here, which is 8 as well. So we have the limit as x approaches 3 from the left of f of x according to what we have. You can see, right? Yeah. So root of that limit will give us root of 8. Root of 8 to give us 2 root of 2, and from the left we use this man. So we have the root of limit as x approaches 3 from the right of f of x. What do we get there? We got 7. So that will be root of 7, which stays as root of 7. If you check now, you see that also f of s fails to be continuous. H of s too will fail because as you can see, h of a is defined but the limit does not match. So we can say that the limit as x approaches 3 from the left of f of x does not match the limit as x approaches 3 from the right of f of x, and this will not also. So because of this, we can say that the function is discontinuous. So h of x is discontinuous, and this kind is called the jump discontinuity, because there is a difference between the limit, and the difference is not 0. So there is a jump. So f of s here discontinuous, h of x here also discontinuous. So thank you, and see you in the next lesson.